Yes, we've got 4-3, which is through chapter 4. So we've got 4-4 and 4-5 of this. But this is kind of our last, official lesson on scatter plots and trend lines. So yeah, Bao has a new tracking device, this guy right here, that he wears when he exercises. It sends data to his computer. How can Bao determine how long he should exercise each day if he wants to burn 5,000 calories per week? So we have this data right here where he's just got, time spent here versus calories burned here. So the idea here is we want to actually make a trend line. And so the idea here is you want to put your trend line through kind of the balance, the average of your points, right? So you want roughly the same amount of points on the top of the line as on the bottom of the line, okay? And so we'll kind of, it's kind of an art rather than a science at this point, because you're just kind of deciding like, oh, I'm going to go kind of like right there, and maybe like right there. And so I'll kind of put my line kind of through there. And that I think is going to be pretty good. Right there. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah, that's fine. Yeah, that's pretty good actually. So yeah, now let me commit to it fully by using a pen, because I just wanted to do that with a pencil and make sure it was okay. Okay. And now what we're going to do is we're going to actually try to generate an equation off of this line. So what we want to do is we want to find 2 points that are on the line, or we kind of just find where it's going to go. So let's see, I've got this point here, which is pretty good. We've got 80 and 700 right there. So this point right there. And then let's see if we can get anything else on here. What did they actually use in the book here? 25,200. Let's take a look at 25,200. Boom, right there. And yeah, that's fine. That's close enough that we can use that right there. Okay, so we'll use 25 and 200. So it's been a while since we've actually done like finding slope and stuff like this, right? So we're going to generate an equation, right? Again, the equation we're going to generate is that. Okay, and we can see that our y-intercept right here is pretty easy, right? It's 0. Okay, so we don't have to actually worry about that on there. We'll actually just worry about the slope. And how we worry about the slope is we figure out the rise over the run. So if we're going from here to here, right? So it goes from 200 to 800, right? So is that 800 or 700? I think it's 700. Yeah, 200 to 700. So we'll figure out the difference there. Okay. So 700 minus 200, right? Remember our slope is y2 minus y1 over x2 minus x1. So then let's say 80 minus 25. Because that's our x values, right? 80 or 25 to 80 this way, right? So this gives us 500 divided by, let's see, 80 minus 25 is 55, like that. And then we will simplify that. I'm actually just going to use a calculator to get a decimal on this. So 500 divided by 55 gets us 9.1, right? So we have a slope of 9.1. So our equation is y equals 9.1x. Oops, sorry, I'm off the grid there. And so we want to burn 5,000 calories per week. He's burning, let's say, he burns basically, what does this give us? Sorry. Let's see, guys. 9.1. Yeah. So 9 calories in about a minute. That's what it gives us. Okay, so he's burning about 9.1 calories per minute, right? And if we want to get to 5,000 calories here, so then we're just going to take. Hold on, guys. Okay, sorry about that, guys. Okay, so this is 9.1 calories per minute that he's burning. And so let's see if we figure out how many per hour, right? So if we do 60 minutes, right, x equals 60 minutes, we just plug that in here. Y equals 9.1 times 60. Okay. And then we'll just say 9.1 times 60. Oops. 9.1 times 6. Come on, Wishart. 9.1 times 60. There we go. Gets us about 546, right? Okay, so that's how much he's burning an hour. And we want to see how long it'll take him to do 5,000, right? Well, if we take this, we multiply it by 10, right? So 10 hours. We just multiply that by 10, gets us to 5,460, right? Which, that's too much, right? If we put in 9 hours instead, so it's 546 times 9, then she gets to 4914, or he does, right? So 9 hours is 4914. So it's in between there, right? So let's say about 9.5 hours. Actually, just over 9 hours is how long it would take him. Okay. Man, I'm all over the place here, guys. Sorry. It would take just over 9 hours of exercise to get to 5,000. Boom. Okay. There you go. Michaela is a speed skater, hopes to compete in the future Olympic Games. She researched the winning times for the past 50 years. If the trend in faster speeds continues at the same rate, how can she use the information to predict what might be the time to beat in 2026? So years after 1960. So this is, we're going to do the same thing. We're going to figure out the slope versus the y-intercept. Right, we got our y-intercept is about 2.4 minutes. Okay, so that's our b value. Okay, we're going to fill in our slope in a minute. It's going to be, we want to find 2 points that are on the line-ish, right? Well, let's get this one right here because that goes directly through it. And right there, and that goes close enough, right? So this one is, let's see, 35 at 2. Not 3.5, 35 years, 2 minutes. And then this one is 50 years and 1.8 minutes. Okay, so then it's going to be, the y value over the x value, right? So 2 minus 1.8 over 50 minus 35. Okay, that gives us 0.2 over 15. Okay. So let's see, 0.2 divided by 15 gets us to 0.01 as our slope. Let's give it 4 or 3 decimals, right? Okay, let's do that again. Sorry, 0.2 divided by 15 gets us to 0.013. Yep, perfect. Okay, so that's our slope. So our equation is y equals 0.013x plus 2.4. The trend might be in 2026. We got to figure out how many years after 1960 2026 is. So basically, we take 2026 and we subtract 1960. Okay, gets us to 66. So 66 years after. Okay, so we'll multiply. That's our x value right there. Okay, so this becomes y equals 0.013 times 66 plus 2.4. So let's plug this in here, right? 66 times 0.013 gets us to that, and plus 2.4. So the time to beat, haha, my bad. This is a negative slope, so this is a negative right there. Okay, my bad. Yeah, there you go. Sorry, this is a negative equation. So what it's actually going to be is, I'm going to clear this out. So let's see. I don't need a parentheses right there. 66 times 0.013 times 66 negative gives us this. Okay, 0.013 times 66. Okay, there we go. That's much better. We make that negative, and then we add 2.4. So that's much better. That makes much more sense. So the time to beat in 2026 is like 1.5 seconds, which is crazy. 1.5 minutes, my bad. Okay. The time to beat in 2026 will be approximately 1.5 minutes. Okay. Yeah, so this is how people like actually do this stuff to make predictions, right? Use the slope, which we just did there. Use the scatter plot to make a prediction. The scatter plot shows the relationship between the number of people at a water park and the temperature, about how many people should the owners of the park expect at the water park when the temperature is 90 degrees. So this is actually pretty easy. So you just go to 90 degrees right here, and you kind of just go up, and we go right here, and we can see that the line is just over that 800. So I would say, as an estimate, you would say, I don't know, maybe 810 people, right? Um, the owners should expect a little more than 800 people to come to the water park when it's 90 degrees. Okay, so super easy on that one because you guys just got to look at the graph. Okay, interpret the slope and y-intercept. The scatter plot suggests a linear relationship with between the temperature and the number of smoothies purchased in thousands. So we're going to figure out the slope and the y-intercept again here. We've got a couple points here that we can use that are right on the money. That one right there and that one right there. So this is going to be 40, 32. Okay, and then 80. What is in between here? 64 minus 48. Okay, divide by 2, so 8. So 56. Okay, so 80, 56. Okay, so x1, y1, x2, y2. So 56 minus 32 over 80 minus 40. So 56 minus 32 is 24 over 40. Now we can simplify that by dividing each by 8, so we get 3/5. All right, so our slope is 3/5. Our y-intercept is 8. Okay, so now we got to talk about this, right? So our slope is 3 over 5. So what that means, let's just kind of like break this down, right? We get 3,000 purchased, 3,000 smoothies purchased when the temperature goes up by 5 degrees, right? So say 3,000 more smoothies are purchased, are sold, let's say, because that's a smaller word, are sold when temp goes up by 5 degrees. Okay, that's the slope right there. The y-intercept is, that just means that 8 smoothies, or 8,000, gosh, 8,000 smoothies are purchased when it's, that's when it's 0, but like, let me see, what do they say in the book for the y-intercept? Oh, when the temperature is 0, yeah. Mm-hmm. Yeah. So 8,000 smoothies are purchased when the temp is 0, are sold, let's say, when the temp is 0. There you go. Okay, guys. We're going to put this in our notebook. Oh, this is going to be, I think, on page 14, something like that. Okay. So page 14, use linear models to make predictions. 4.3. right?